everyone, welcome back to the tutorial of low level design. And in this particular video we are going to see the uh, tight coupling problem of normal inheritance that we used to showcase the open close principle. So in the previous video we saw the code for this class diagram. um, we had a cake class, we had two classes, pineapple cake and chocolate cake, which extends from this cake class. And this was the thing, and this particular cake class was open for extension. That is why we had this pineapple cake and chocolate cake classes, and closed for modification, so we cannot modify this particular class. Now suppose we want to add, now what was the problem with this inheritance? So this was the hierarchical inheritance, or it's a normal inheritance. So the problem with normal inheritance is that it forms tight coupling. So what does that mean is the classes are highly interdependent on each other. So suppose we want to have like if we want to have, so we had this cake method over here, or this pineapple cake and chocolate cake. Okay, pineapple cake and chocolate cake, these were the constructors. Now suppose that we want to have uh, desired base for each cake. Suppose we want to have base, so let's suppose here we want to have base as well, base which is a private and type string. And this chocolate cake class should also, we want to also have this base over here, base. Now as the sales grow, we wanted to have one extra thing, that is base, desired base for each type of cake. So for this purpose we have to make certain changes. So what changes we have to make? First of all, we will see in the code, we will have to change this constructor parameters. So this constructor parameter was taking size, weight only. Now it will take base also. This constructor parameter will also take base as its parameter. And also this we have to make certain changes in this class as well, which is the cake class. So if we want to add some new features in one class, we also have to change the parent classes and all the subclasses as well. So this is what is called tight coupling, that the classes are highly dependent on each other, and we do not want to we will be, as a programmer, we want to avoid the tight coupling problem. So we have to do decoupling. So for this reason, the inheritance, like open close principle, can be implemented in two ways, using normal inheritance and using interfaces. So for this purpose we have this method 2. We have this method 2. So before going to see the method 2, what is method 2? That the open close principle can be maintained using interfaces or abstract classes with overriding functions, overriding methods. So before seeing the method 2, let us quickly try to add these data members into our base classes, and also do certain modifications that are needed, so that we can understand how this tight coupling problem is coming, how how this tight coupling problem is encountered. Let us see. Okay, now we had written this code of this bakery shop sales, and suppose the sales have risen in the initial in the um, recent days. So we want to have desired flavor for the pineapple cake class, and uh, for different cakes that we have made. So for chocolate cake and for pineapple cake, we want to have some flavor as well. So what modifications we have to do in this code? So all the modifications that we are going to do in this code will eventually show us that how the classes are highly interdependent on each other, and how the problem of tight coupling is uh, coming in this code. So suppose we want to have this we want to have flavor here. Okay, so what we will do, we will write here private string flavor, and we have to take this string flavor here as well, string flavor. And in this we have to give the constructor this flavor also. So if we are going to give flavor to the constructor, then we have to take here flavor as well. And we have to make here flavor private string flavor. Okay, it is string flavor, this dot flavor equal to flavor. So what we did, actually we added one extra parameter flavor over here. For that we declared flavor over here, and uh, when we modified this pineapple cake class, we also had to do certain modifications in the cake class as well. So this cake class and its child class pineapple cake are highly interdependent on each other. Modifications in one class resulted in doing modifications in another class. So this shows how tightly coupled they are. So these cake and pineapple cake are tightly coupled. Again, if we want to have here flavor, so we have to add extra parameter flavor over here also. So see, doing changes in this class resulted in doing changes in this class, and we have to make changes in this class as well, because this is giving me the error, because this constructor is undefined, because it should take extra one more parameter over here. So I have to give here flavor as well. So I will write here string flavor private string flavor, and this dot flavor equal to flavor, and we have to pass flavor over here as well. Okay, so this way we are able to solve the problem. But you can see these three classes are highly dependent upon each other. Changes in one class resulted in making changes in another class, so that our code can function well enough. So this shows the tight coupling problem, and we will pass here one more parameter. Suppose we have vanilla, we have flavor as chocolate, okay. Now let's make some changes over here also. We have added one more parameter flavor over here. So this dot flavor I will just print out, and flavor is this dot flavor. Okay, this dot flavor. Now just run it. Just try to run this. can also show the flavor over here as well. Flavor is vanilla, flavor is chocolate, so it is showing. And this was it. So in this so we saw how the tight coupling problem is encountered, and how we can solve it. Now let's see how with the help of interfaces we can solve the problem of tight coupling by decoupling things. Now that we saw that how this tight coupling problem comes in case of using inheritance, the normal inheritance. So now we are going to going for the interfaces or abstract classes method to implement this open close principle. So again we have this bakery shop. Now see that we had this chocolate cake and pineapple cake as the base class, but now we have an interface. This is called interface. We know that classes communicate with each other with the help of message passing. uh, Now we have this interface over here. So this interface, so these both classes are implementing this interface, and this interface is having three uh, three methods, that is bake, add cream and decorate cake. Now now when we have to add these now that we have to add these data members into the pineapple cake and chocolate cake class. We can easily add them and we do not need to like do certain modifications in the interface. We do not need to do certain modifications. So this interface is like eradicating the problem of tight coupling. So it is helping to decouple decouples decouple the things, and uh, it is useful for loose coupling. So interfaces provide loose coupling. How they are providing loose coupling we are going to see, but just remember that when we are using an interface, so these methods are actually uh, are by default abstract methods, and we are going to see how this interface is helping in maintaining the open close principle with loose coupling and eradicating the problem of tight coupling. Okay, so now we are going to see the open closed design principle using interfaces. So what interfaces will do, it will help in avoiding the tight coupling and keep everything loose coupled, so that there is no interdependence between the classes for which we are going to use interfaces. So let us see. So as we did before, on the right side we have the blueprint, the class diagram, and in the left side we are going to code it out. So the code will not be much different from the previous code, but in the previous code we had cake class. Now here we have cake interface. So let's code it out. So first of all we are going to have import java.io.all, and let's create cake interface. So interface cake, and we are having three methods, bake, add cream and decorate cake. So and they are public void bake, public void add cream, public void decorate cake. And always remember that all these methods that are in this interface are abstract by default. So these all are abstract, so these methods are abstract. so we can clearly use them in function overriding. Now this interface, we have created this interface. Now we are going to create the chocolate cake class, which will implement pineapple cake class, which will implement this interface. So let's create it. So we are going to create class pineapple cake, which is going to implement this cake interface. Now we have to actually what we will be what it's giving must implement the inherited abstract method add cream and decorate cake and bake. So we have to implement it because these methods are abstract. So abstract methods must be implemented in the classes which are implementing or inheriting the abstract class or abstract methods. So abstract methods must be inherited. So let's create so we have a base string. So private base string, we have private size, private int size, and private int float weight, and we have a pineapple cake constructor. So public pineapple cake constructor, and in this we are going to take string, private string base. Okay, now we are going to take string base over here, and int size, int weight, this dot base equal to base, this dot size equal to size, this dot weight equal to weight. So this much is done. Now we will be using the add cream, decorate cake and bake method. So we have decorate cake over here. So the decorate cake we have to create, we have to use, like, we have declared the method over here, but we haven't put its functionality over here. So if we want to put its functionality over here only, then we can use we can do so by putting one default over here, but it will so if we are using default, then we can just write over here we are given the functionality over here. If we write default with all these things, so what will happen, you will see default. If we write here default as well over here too, and over here too, then you will clearly see it will not throw any error. But if we just remove everything from default, then it will throw the error that it must implement the inherited abstract methods. Okay, so for simplicity's sake, we are not going to add default keyword before the methods in this interface, and we are going to make methods in the inherit classes that are implementing the interface. So in the pineapple cake class, we will have a add cream. So public void add cream, we have to use them. So add cream, and In the add cream we are going to add pineapple cream. So system dot out dot println adding pineapple cream, and this is done. Add cream is done. Now we can have a bake public void bake public void bake. Now what this will do basically, it will bake the cake with base. So it will print system dot out dot println baking the cake with base. Suppose this dot base, it is going to print this dot base, it is going to print base. Now let's just call for add cream method. So it will call for add cream method, and also it will call for, suppose it will call for decorate cake method. So we have to create one decorate cake method as well, decorate cake method as well. So suppose we just call for decorate cake method. We haven't created a decorate cake, but I will create it. And also I am going to print the dimensions of the cake. So system dot out dot println dimensions of the cake, this dot weight plus this dot size is the dimensions of the cake. This is done. Now I will also create one. So again, why I did not create this decorate cake method, so as to show you that we have to implement, we have to create, it must implement all the inherited abstract class method. Okay, so it must implement decorate cake also. So let me just create public void, all the abstract methods must be implemented. So yeah, decorate cake and cake decoration with something system dot out dot println cake decoration with pineapple chips, suppose pineapple chips. This is done. So in this way we are implementing this cake interface. So what things we have to keep in mind? We just have to keep in mind that this interface is having abstract methods by default, and the classes that are implementing this interface must have the function signatures, of the decorate cake, of all the functions that are abstract. Okay, this is done. This is what abstraction is. Now now we can actually see that previously in the previous video, in the previous method we saw, in the previous method what we saw, that the cake class was having these the cake class was having some of the methods, and we had to change the constructor, we have to make a new base variable, and we have to assign it to constructor. So the base class that was the cake that was the base class needed to be modified when we modified the derived classes. But in this approach, when we are using interface, we need not to worry about all the classes. If we are changing something of this class, then if you want to add a new flavor over here, like a new flavor, then we do not need to modify the interface. So this provides loose coupling. so loose coupling is provided. Now let's create this chocolate cake class as well. So as we can see that this chocolate cake class is having the same data members and member method functions as of this pineapple cake. So I will just copy it, just name it as chocolate cake and constructor as chocolate cake and the same things, and I will just decorate it with choco chips and chocolate cream and the base, the dimensions, everything remains intact. So this is also implementing the cake interface, and we can have other we can modify this class without changing other classes. So this is what it is this is what loose coupling is. And let's create the main method. Let's just create the main method. So class baker shop using interface public static void main string. Now let's create the object. So let's create a pineapple cake. So cake I will use. So let's create a pineapple cake. So cake pineapple cake. Cake pineapple cake is equal to new pineapple cake. Okay, and we will have base as suppose vanilla, size is 2 and weight is suppose 4, suppose 3. Okay, so what I am doing over here, am I doing over here, it's giving error because cannot convert from pineapple cake to cake. Why this is happening? So yeah, okay, we can create the object of object pineapple cake, but we can also write here cake as well. It won't show, it should not show any error, but why is it showing the error? Because let me see, we have one interface cake. Okay, so it is capital in capital letters. Okay, let me just write, it should be capital. It should be capital because no, my bad, I was using small letter. So interfaces start with capital letters. Now it's fine. So I am using, so always remember that we can have references of this cake interface, but we cannot have instances of this cake interface because interfaces can't have instances. So let me explain over here. So if I have made one interface, suppose this is interface A, suppose interface capital A. So if I have made interface A, so I cannot write here A some like A some name like an NAME name to use the interface, or let me write over here test, A test. We can write A test, so it will be, it's giving error, but just understand that we have made one interface A and I can write here A test. This means that I can have references of this interface. But if I will try to write equal to new a, if I will write like this new a, then clearly this interface cannot have instances, so this test instance cannot be created. Let me just clear you with one more example. Suppose we have class a, suppose we have class b, and we are writing here b obj equal to new b. It is completely fine, it is completely fine, because classes can have objects. So what is object? Object is an instance of this class b, but interfaces cannot have instances. So a test is equal to new a is not allowed. It is not allowed, it is not allowed. But what if I will write a test? It is allowed, a test is allowed, a test is allowed, because uh, interfaces can have references. So this is a reference, and it can refer to obj, it can refer to obj. And what is this obj? Obj is nothing but suppose I write here a class imp. So I have written here class imp. So test is a reference, and what is this? This is the class that is implementing that interface. Suppose any class, suppose I am writing here class void, suppose I am writing a class imp implements a. Suppose I write something like this. So this class imp is a class that is implementing a. So we can have a reference of this interface which can refer to the class implementing that interface. So this is allowed. So this is the thing that we did over here. We are using interface and the reference. So interfaces can have references, and it can refer to the class implementing that interface. So this class is implementing cake interface, so we can have a reference of pineapple cake as of that. So this is what it is. Let me just remove all these things over here. So in short, what I was trying to tell is that classes can classes can have interfaces. Classes can have instances that are called objects. Classes can have instances that are called objects, but interfaces can't have instances. And but interfaces can have references, and these references can refer to the classes that are implementing that particular interface. Okay, so this is the thing that I was trying to tell you. So this is done. So I have created one instance, and it is referring to the class that is in implementing that interface. Now what I will do, let's write here pineapple cake dot, and it has a bake method that is overridden. Okay, so bake is the abstract method that has been overridden in the pineapple class that is implementing the cake interface. So this is what it is. And now let me write over here cake chocolate cake new chocolate cake, and I can write here choco base is 223. This is done, and we can use to access the bake method. Let's see the output. So this is the output that it is giving. Let's just write over here system.out.println So this is how this code is working. We saw that how interfaces help in reducing it is helping in decoupling things, and how we showed loose coupling. We showed loose coupling because changing anything in this particular class, so all the classes are independent of each other because of this interface, so it is loose coupling. And how interfaces are useful we saw. So if you are not using interfaces, then you are like if you are using Java, and in Java you are not using interfaces, then you are not using the full potential of Java, because no other programming languages like C++, Python, they do not provide interfaces, but Java provide interfaces, due to which we can have loose coupling, which helps in like retesting and debugging. It makes easier, we can, and our software becomes super scalable. So this was all about open closed design principle. We are going to see the next principle in the next video.